Welcome back. In this section, we'll be solving quadratic inequalities. We've already looked at solving linear inequalities, and for those we were able to solve them algebraically, moving numbers from one side of the inequality to the other, isolating the variable, and then coming up with a solution. And unfortunately, we run into a problem with quadratic inequalities and actually anything that's nonlinear. And that's because for quadratic equations, we have techniques to help us out when we've got something like x squared equal to a number. We have that square root property that says, oh, well, x should be plus or minus the root of that number. Unfortunately, we don't have a similar sort of property to help us out when we're solving a quadratic inequality. So if I were to change this from an equals to a greater than or equals, when is x squared greater than or equals to 9, it's not just as simple as taking square root of both sides. Unfortunately, there is not a quick and easy way for us to do this. However, we can use graphing to solve the problem, and that's actually kind of a faster way to do it anyhow. Because when we're thinking about parabolas, if we're thinking about any sort of quadratic inequality, it could be rephrased as a quadratic function being greater than 0 or less than 0 or greater than or equal to 0 or less than or equal to 0 when we rewrite the inequality so that we've got 0 on one side. And once you have that, then the question is really one of where is this parabola above the x-axis or below the x-axis? So if you have some sort of quadratic function greater than or equal to 0, you're looking for where is the graph of that function above the x-axis. If you are looking at some quadratic function being less than or equal to 0, you're interested in when is it below the x-axis. And so for that, all we need to know is the rough ideas of what does this parabola look like? Where are its x-intercepts? Is it opening upward? Is it opening downward? And of course, if it doesn't have x-intercepts, then it's either always opening upward or always opening downward. And if we just use a little bit of common sense, we'll be able to figure out which of the two it should be. So for all of these problems that I'm going to be looking at, they'll all turn out to be quadratic inequalities, but ones where essentially we're going to come up with our answer by thinking about the graph of a parabola, graph of that quadratic function. So, for example here, if you're looking at this function f of x, if you were interested in solving the inequality where is f of x less than or equal to 0, in other words, where is x squared minus 1 less than or equal to 0, you'd be interested in where is this parabola at the x-axis or below it, and that's everything between -1 and 1. So you can say either in set notation or interval notation. If you were interested in f of x being greater than or equal to 0, then you'd be interested in where you at the x-axis or above it, and that would be everything up to -1 or after +1. So again, you can express that in set notation, or you can express it in interval notation. And if these had been, instead of less than or equals to, if it had just been a strictly less than, then we would not be including those points where we were equal to 0, where we're at the x-axis. So we'll have to be a little bit careful when we're thinking about things, and we will have to pay close attention to whether it's a strict inequality, one that doesn't include the equals, or whether it does include the equals. But for all of these, it really will boil down to what does this quadratic function look like? Okay, so to start out with the first one, we're going to start by solving it, and it's already written where we have everybody on one side and 0 on the other. So the quadratic function that we're thinking about here is the quadratic function y equals x squared plus 8x, which easy enough for us to find those x-intercepts if we wanted to. We know the x-intercepts would be at 0 and at -8. We also know that since the coefficient for the x squared term is positive, that it's a parabola opening upward. So whatever we're looking at here, it's a parabola opening upward. It crosses the x-axis at 0 and at -8. So the question that we had is, where is this less than 0? Where are we below the x-axis? And the answer is we're below the x-axis between -8 and 0. And I'm going to write this one in interval notation. So it's the interval from -8 up to 0, not including the 8, not including the 0. So round brackets for both. And of course, it's not including because we're looking for where is this parabola less than 0? Where are we below the x-axis? It's not equals to. We're not interested in equal to the x-axis. We only want strictly below it. And of course, if you wanted to write it in set notation, you could say it's the set of all x such that x is between -8 and 0, not including the -8, not including the 0. All right, next one up. Before I start doing any work with it, I'm going to start by rewriting it so that I have everybody on one side and 0 on the other. So the parabola that I'm looking at here, y equals 6x squared minus 5x minus 6. And that definitely opens upward. And then now you've got a couple of choices. If you want to find your x-intercepts for this parabola, again, you can find them by trying to factor. And I suppose that's one way to do it, but remember that we don't always have to stick with factoring. In this case, it's a quadratic function, so you could use the quadratic formula, and that's probably faster here. Basically, you have to make your choice whether you're going to factor or use the quadratic formula based on which one you're faster and more comfortable with. I wasn't telling anybody here how to solve for x, so if you wanted to solve using the quadratic function, or using the quadratic formula, you certainly can. And so easy enough for us to find those two x-intercepts. So inside my square root, I'd have -5 squared, which is 25. I have -4 times 6 times -6, which is 144. And together that adds up to 169. And square root of 169 is 13. So I have 5 plus 13 over 12. And so I come up with two values for x. X is either 5 minus 13 over 12, which is -8/12, which is the same thing as -2/3, or 5 plus 13 over 12, 18 over 12, which is the same thing as +3/2. So we're pretty much good to go now because we know that this parabola is going to cross the x-axis at -2/3 and at +3/2, and that it's a parabola that's opening upward. So for the question that we were given, which is, where is this parabola greater than or equal to 0? We're interested in where are we at or above the x-axis, and the answers would be everything up to -2/3, including the -2/3, and also everybody after the +3/2, including the 3/2. So for my solutions, I would say it's everybody up to and including the -2/3, together with everybody from the 3/2, including it, afterwards. And there we go. That's my solutions written in interval notation. One more to do here. We've got another function, and this is already written with everybody on one side, 0 on the other. So our parabola that we're talking about here, 3x squared plus 2x plus 1. Again, it's a parabola that's opening up. And the next thing that we need to do again is find our x-intercepts. And we do that by letting the y value be 0, and solving for x. And again, I'm not going to bother trying to factor here. Instead, I'm just going to use my quadratic formula. And then we run into a problem pretty quickly, which is that inside the square root, that happens to be negative. 2 squared minus 4 times 3 times 1, that is negative 8. And so that means there are no real solutions, which means that there are no x-intercepts. And so that means we have one of two options happening. If there are no x-intercepts, either the graph is always above the x-axis or the graph is always below the x-axis. And this is where we need to use a little bit of common sense. We know that the parabola is opening up. So if the parabola were ever below the x-axis and it opened upwards, it would eventually cross the x-axis somewhere. So that means we couldn't be below the x-axis. The only way that our parabola could open up and also have no x-intercepts would be if our vertex was somewhere above the x-axis, and then we would always be above the x-axis. So, for this parabola to make sense, we would have to look a little something like my really rough sketch that I've got going on there. It must be something that's above the x-axis, and it must stay always above the x-axis. So the question is, where is it less than or equal to 0? The answer is nowhere. There are no solutions to this. So you could say this in a couple of ways. You could say in words, no solutions. You could also write it in set notation by showing a set that has nothing inside of it, two curly brackets with nothing inside. Another way of expressing no solutions is through the use of what's called the empty set. It looks like a 0 with a slash through it. It is not the number 0. This is a representation that we have for a set with nothing in it. So it's a way of symbolizing nothing, no solutions. All three of these would be fine ways for you to write your answers here. So because it opens upwards and because it has no x-intercepts, we know that it must be always above the x-axis, which means that there's no solutions to where is it below or equal to the x-axis. It's never at the x-axis, and it's also never below it. You can also see quadratic inequalities coming into places like this, where we have a function like this f of x, and we want to know what's its domain. And the thing that we know, of course, is that for root functions, square roots, fourth roots, sixth roots, for those to be real numbers, the inside would need to be 0 or larger. So when we're asking ourselves about the domain of this function, we're asking ourselves the question, where is 5x minus x squared greater than or equal to 0? And for that, it's a parabola that we know happens to be opening downward. This is a parabola where we know that it opens downward because the coefficient of x squared happens to be negative. Also, you can factor out fairly quickly and find the x-intercepts are at 0 and at 5. So our x-intercepts at 0, 0 and at 5, 0, and it's a parabola that opens downward. So where are we greater than or equal to 0? Only for these values between 0 and 5. So the domain for my function, I could say that it's all the values between 0 and 5, including the 0, including the 5. Or I could write it in set notation, set of all x, such that x is between 0 and 5, including the 0, including the 5. All right, one little last problem to do, and this is, again, more just interpreting graphs. All of these problems that we have for solving where is f of x equal to g or where is f equal to 0, we can interpret those all visually. So, for example, when we're looking at where is f of x equal to 0, we want to know where are we at the x-axis. Where is it less than 0? Where is that function below the x-axis? And when we've got two functions being considered, then if you're looking for something like f of x to be equal to g of x, where do they have the same coordinates? Where do they cross? So in other words, where do these functions intersect with each other? If you're looking for where is f of x greater than g of x, you're looking for where is f of x above g of x in our graph. If you want f of x to be less than or equal to g of x, then f of x needs to be below or equal to g of x. So here, the two functions that we've got, f of x, this is our parabola that we've got, and g of x, that's our little straight line function. So for part A, asking where is f of x equal to 0, that's asking where is our parabola equal to 0. In other words, where are the x-intercepts? And the answer is when x is 1, and also when x is, negative 1 rather, and when x is 3. So since this is just 2 points, I'm writing it in set notation. My solutions are the 2 points, negative 1 and positive 3. For part B, solving for where is f of x less than 0, where is our parabola below the x-axis, that's an interval of values. It's all the values between the negative 1 and the 3, so I'm going to express this in interval notation. It's all the values from negative 1 up to 3, not including the negative 1, not including the 3, because that's where it's equal to 0, and we just want where it's less than 0. For C, we're looking for what are the x values where these two functions have the same y value. So where is our parabola crossing with our straight line? And we know that there's two places that it happens, when x is negative 2 and also when x is 1. So again, there's only two solutions here, two values. So I'll use set notation. The two values are negative 2 and positive 1. Those are the two values for the values that make our two functions equal to each other. For f of x greater than g of x, again, this is f of x being our parabola, g of x being our straight line. We want to know where is the parabola above the straight line. So this is where we need to look at our graph and say, well, when we are in this region, when we're to the left of negative 2, and when we're in this region to the right of positive 1, that's where our parabola is greater than our straight line. That's where we're above the straight line. So my solutions for D would be all the values up to, but not including the negative 2, together with all the values that are larger than 1. I'm not including the negative 2, and I'm also not including the positive 1, because we're looking for where is the one function strictly greater than the other. Negative 2, that's where they're equal to each other. 1, that's where they're equal to each other. That's why I'm not including the negative 2 or the 1. And then finally, for part E, we're looking for where is f of x less than or equal to 0. So where is our parabola at this straight line or below it? So if we're looking at that, we are at the straight line or below the straight line in that little region there. That's where our parabola is either at or below the straight line, and that would be all of the values between negative 2 and 1. Here I am going to include the negative 2 and the positive 1 because those do make the two things equal to each other. Those are x values where f is equal to g of x, and we're including where they're equal to each other. So I have here that my f of x is less than or equal to g of x in that whole interval from negative 2 up to positive 1, including the negative 2, including the positive 1.